networks, which consists of the network of devices and computers connected through a series of intermediate technologies, where numerous technologies like radio frequency identifiers, wireless connections may act as enablers for this connectivity. The basic components of this structure include what we call tagging things, feeling things, sharing things.
Sir, sorry to interrupt you, sir. Your screen is not pinned, sir. So we are not able to see your PPT screen.
I'm sorry. 1 minute. I'm just highlighted. The structure of the IoT I'm speaking. This.
Participants, you have to pin Professor Ramamurthy sir presentation.
Hello? 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 Yeah, man. Hello?
Sir, if possible, kindly share it in the entire note, sir. From
I will share it. I will share. Okay. I'll share. Please see here. Let me come just complete for some extent, then I will share everything. See, what I said is, yeah, it is structure basically is a combination of many things like, tagging things, feeling things, shrinking things. Hello? Hello? Hello, madam. Hello? Prema. Yeah. I'm just sharing. Please here. Are you able to see the slides? Okay. Entire screen, entire screen. Is it okay now? Hello? It's okay? Is it fine?
The screen is visible now, sir.
Entire screen there. Entire screen. I am on the entire screen process. Entire window. See this. Just have a look and tell me.
Entire screen.
Okay, fine. I'll continue it. Okay. Yes, sorry. Right. I apologize for the dislocation. I am sorry. See, basically, what I was speaking is, it is a case, the structure of IoT, it consists of a collection of things, I said, in which tagging things, feeling things, syncing things, and thinking things. These are the combination of this. And then, what is the tagging thing? Basically, it's a real-time item traceability and addressability with the aid of RFID. By RFID or with the aid of RFID, we call it as. And then feeling things comes to sensing the act. Sensors, they will act as a primary device to collect the data from the environment. Then shrinking things, it is nothing but miniaturization of, and nanotechnology has provoked the ability to bring the entire largest spaces into smaller spaces or into a compact size. In that context, this will shrinking things will help you. See, basically, as I said, miniaturization of and nanotechnology has provoked the ability for bringing them a larger shape to smaller shapes in order to have a better interaction and have a better connectivity of things, or simply we call them together smart devices. Okay, and next is thinking things. Basically, this is actually a component related with embedded intelligence, because you need to have you have some intelligence, and that should be in embedded form. That is possible if you need to create such devices which by the help of what are called sensors, and they have formed, and it basically look at the network connection to the internet. It makes the things realizing the intelligent control, makes the things realizing the intelligent control and intelligent control. Now let us see this. These are basically what the current status. I say there are several. If you compare from 2003 to 2020, there are current status and future prospects of IoT is increasing like anything. So 500 million to 6.3 for worldwide population. When you are having it's only 0.08 connected devices were there. Now, when you come for 2010, 1.84 like this, you can see if you today, the last year, it is from the last year statistics, it's observed that 6.58 connected devices per person are using among 7.6 billion people. So this is where change is the only thing, the thing permanent in this world. That's what it has established. Now, next comes under what is called the basically how IoT as a network it works. Basically, you know very well, as far as networking is concerned, there are three types of models are there, and there are none other than three-layer model, 5-layer model, and 7-layer model, which is OSI we call it as, and In addition to that, then they have introduced what is called TCP/IP also has come. I will speak about that. So Internet of Things basically it's a combination of individual networks, connected networks together with a clear emphasis on security and the analytics, and also how best you can manage. So these networks connected with added security, analytics, and what you call management capabilities. This will allow IoT to become even more powerful in what we can say people and achieve. That's what people can achieve. So now let's go to next. See, now when we speak about this, what is the potential of the IoT? Which is potential among the IoT? Is basically that who is using it, which context they are using it, because it is related with value of the industrial internet use, because day by day it's increasing. As for the industries are concerned, if you think from aviation, power, healthcare, rail, and oil and natural gas, these things, if you see, we have got what we call 90 billion, what is ONGC using it, and rail is using 27 billions, and whereas healthcare is 63 billions they are using, and power is 66 billions, and the aviation technology they are using it 30 billions of United dollars or US dollars. That means GE is estimating on a potential of just 1% saving applied to using the IoT across the global industry. Now let us see this. What exactly is the roadmap for this? See, the roadmap is very simple. First, you have RFI. I will say there are 4 components are there. The 4 components include first, supply chain helpers will be there, and vertical market applications, ubiquitous processing, and physical world web also. Physical world web also is required. So now, if you happen to plot a graph, these two with time and the technology that is reaching the people, if you draw it, this is what the roadmap is. See, basically, supply chain helpers consists of RFID tags and tracing, routing, and inventing, and loss of prevention. And the next you have is this basically we call it as a demand and expanded logistics. We classify that. Similarly, you have surveillance, security, healthcare, transport, food, safety, document management. This nothing but it is a vertically what you call market applications it deals with. And this is basically involved with cost reduction, leading to diffusion into second wave of applications. Similarly, you have what we call ubiquitous processing. This is basically locating people and everybody's objects you have to locate. And then you need to have ability of devices that are located indoor to receive geographical signals. That next is you need to have physical world web. This is basically deals with the tele-operations and tele-presence ability to monitor and control disjoint objects. So it is we classify it to be as miniaturization power, we call it as, and efficient electronics and available spectrum. Then next comes under what is called, you need to integrate all these things with the aid of software agents and advanced sensor fusion. That is the roadmap that what we have. Now let us see this next. See, next is you have whenever you are dealing with such roadmap, definitely there will be certain challenges will be there apart from risk in the adopting IoT. The challenges which are nothing but these are basically securities, and then next is privacy, interoperability, then it's standard legal. Standards of the legally permitted are regulatory rights and emerging economy and development issues. Then next you have what you call how you are going to apply this. So basically, few applications I will cite, because if you look into this, there are everywhere on the sun, universe is there that you can apply for this IoT. Therefore, here let us see these. A few applications I want to tell. The few applications include smart buildings, building and home automation, manufacturing, medical healthcare, media, environmental monitoring, infrastructure management, energy management, and then transportation as well as agriculture domain. I will give what you call one application on which I have done a good piece of work in the domain of the agriculture domain. I will tell at the end about that. See, now if you go on naming that, you can name anything and you will have an IoT in it. That's what I say. Right. So next, if you look into this also can be applicable in efficient waste management, smart cities supported by sensing as a service. Sensing as a service. Okay. So if you look into this, for example, there is Infrastructure across the energy sources and long range data communications will be there, and they'll be taking care of all these things with data with the aid of the what we call low cost passive sensors. We will deal with them, and then they'll be converted to a cloud, and where one can seek for notification in order to keep the city to a smart city. That includes, like example, city council, recycling plants are there, manufacturing plants are there, health safety authorities are there. Ultimately, all these things combination will come out in the form of a smart house. This is what I said. So now let us see this. Suppose if you look into this, next what happens, IoT application scenario. This is basically everywhere today, every e-commerce application, if you take into consideration, there are many applications are there. For example, when you are entering what do you call a mall or shopping complex, when you are entering, the doors sensors will be there. They'll scan the people who are entering into that, and then they will identify with a tag on their on their clothing. Next is when you shop the market, the goods will introduce themselves. So the next is when moving the goods, the reader will tell the staff to put them in one, to put a new one. So when there is like a payment mechanism is concerned, when you are coming to for payment, what is paying for the goods, the microchip of the credit card will communicate with the check out reader. So this is another example I said. Now let us see the next. How well do I sleep? This is another example for health basically. So this we are using some wearable IoT tools we are wearing, and then based on that it can be judged whether your sleep is perfect or not, and how long you have slept, and all these things can be recorded in this. See now I want to know about myself. When I wanted to know about myself, whether I am fit for today's going for office or for working or not, then this I have to see it. Where are you going? Why? Who are you going? Whom are you going to interact with you? How long you are going to speak with your friends, and the affinity of connections, how long it takes to get work, and the tone of your messages, and then amount you text, tweet, and update. How much exercise you are getting, and how much you get distracted. All these things can help you with the aid of IoT, and IoT can help you in knowing about the status of ourselves and the sense body status. See, next. We shall see first, let us see, this is now, next I will go to the IoT in agriculture, because this is my interest actually. So, what is this actually? How are you going to use IoT for agriculture? See, vehicle, and you have pets, and our thing is that agriculture, and then energy, we have energy resources, energy temperatures, security, and then these are our things, and building material, and then how are you going to use the IoT here, and how are you going to make embedded model, embedded mobile, everything in the house can be controlled with this, and then that's what we have. Now, IoT for irrigation, I will see. See, what is this actually? You wanted to supply water for the field. How are you going to do that? We need what you call wirelessly connected sensor control water flow in the field. This saves wastage and get activated only when the soil gets dry. So this is automatically we keep the temperature and see that, and adjust the different sensors functionality, and then see that the required amount only will be poured into that field. And for that, let us see the next what we have is. See, let's see. This is a field you have. You keep one dashboard, and then from this you can have an access, and you can control with your smartphone you can control it. So now different kinds of applications, when you speak about it, there's a lot of variations of applications ranking is there in that smart home, wearables that I told you, smart city, smart grid, and industrial and internet, and connected car, connected health, smart retail, and smart supply chain, smart farming. So of which our interest is a smart farming. At the end I will tell the application for that. See now, wearables. What is it actually? The second hot area of IoT after a smart house is nothing but the second hot wave is nothing of IoT is the connected with smartphones. This devices worn on wrist. You have to wear them on wrist, and smartwatches, Samsung Gear. This is another device that you are using it. Devices put on like a spectacle. You can use in glasses, Google Glass we call it. Smart garments you have, like skin color, tattoos, patch like sensors. All these are basically they come under what is called wearables. Now as far as the smart cities is concerned, smart city includes how you are going to control the traffic, how you are going to manage the traffic, and how you are going to distribute the water for the people who are going to stay in the city, and how are you going to minimize the loss, and how the waste management can be taken, and how urban security can be provided, and how environmental monitoring can be provided. So under these categories, many smart city solutions have promised to elevate real parts of the life living in cities. These days, IoT solutions in the area of a smart city solve traffic congestion problems. They reduce noise and pollution and help make cities safer. Okay. This is what you have. Based on that, we have given some this thing. This is basically smart city, how this house is located. There will be security, alert systems are there, connected cars are there, mobile centric, and you have public transit will be there, and smart automation, and all the combination of these will help you to have a smart city. Right. Next. Now, basically, the most important of the smart city, grids. Power grids. How are you going to take care of the grid? Power grids, for example. Smart grid uses information about the behaviors of the electricity suppliers and consumers in an automated fashion. This technology will help you in delivering the power in a more efficient way. And improve various kinds of operations, and also it reduces emissions, management costs, and also minimize the eddy current loss, as well as restoring power failures in a faster way. Right. Of course, how it's going to help, I will just tell in a few minutes about restoring power failures. See, next, smart grids. See, smart grids basically we maintain in this. What happens, all the things are connected in this. Ecological vehicles, wind generators, renewable energy pumps, photoelectric, hydraulic power generators, thermal power generators, nuclear power plant, and factories, homes, and cities, and offices. And you need to have an ecological vehicle is required, because you need to balance the pollution, because that is being emitted by on account of the release of. For that also, you need to have a smart grid. Through smart grid, you can, with a smartphone, if you wanted to have an application, it can be separated into two categories. One is you can use a mobile vehicle in a vehicle applications, then vehicle to vehicle applications can be used. In that, what you have is a connected car will be there, and that there is what you call in that there are embedded, which includes a camera system will be there, seamless connectivity with infotainment and onboard diagnostics. In case if there is any fault, to identify that will come in the form of an alarm or a signal on the dashboard. Okay, right. Now, to do all these things, we use a concept of statistics called supply chain. We use supply chain management, we use it. The supply chain management is a part for smart supply chain. We call it as an IoT. This IoT solution for supply chain include gaining the user's insight, creating the fleet efficiencies for optimization, and also life cycle visibility of the product, and understanding the inventory levels and warehouse stock, and also combine them together and make in the form of the product in order to perform in an excellent way, so that there will not be much wastage you have to create. So that gives nothing but you need to every component you have to use, you have to supply using supply chain management, and see that efficiency is being drawn in all aspects. Right. Next. Now, this is, I am giving the very important thing. What is that? Everything everybody will tell. But technically, what is that? That you have to be aware. See, the technical elements of IoT is nothing but it's the RFID I told you. RFID you have to implement. Radio frequency identifiers you have to implement. For example, tagging things. Real-time item is only meant for traceability and addressability by RFID. We use this basically in what we call digitization of all the libraries. When the people are borrowing the books, everything, we are keeping an RFID tag on every book, and then immediately the borrower name, borrower identity will be recorded there. If they provided, if they were what we call identity card of the respective organization that you are using. Now, that's why Technical element in RFID implementation, I said to be as the basically it's a real-time item which will trace and which will attain the address of the person. So that you require this thing, RFID tagging be required. Then next comes under what you call IoT communication tool. This is a very important thing. Without this, the thing will exist. Because, you know, as when you speak about the communication is nothing but transfer of message from one to the other. We have to do it. How are we going to do it? And what made the transmission or what made the communication to be effective? All these things you have to take into consideration. In that context, when you speak about it, IoT communication tools and protocols, that will come. See, for example, as I told you, IoT basically is again another extension for OSI or TCP, whatever it may be, you can say. There you have communication tools, you have to use it and then design certain protocols. Like, you know, as you are having a model of OSI in which there are 7 layers are there, as you know, data link layer. Then you have what do you call? I will just. There is OSI level you have. This is physical layer. You have data link layer. You have network layer. You have and transportation layer. You have and session layer. You have application and what do you call presentation and application that you have. In the same way, here also all the protocols also will be functioning. But only thing is we use different protocols for different layers here. In that context, let me tell you one. Think, for example, I wanted to have data link layer protocol. In this, what you have is simply, I say link layer protocol. This includes 802.3 Ethernet, 802.11 Wi-Fi, and it also includes 802.16 WiMAX also, and 802.15.4 is because depending on the rate. Are you going to use more data rate, or are you going to use for a low data rate? So accordingly, Wi-Fi will be used, and then 2G or 3G or 5G or 6G, whatever it may be, it has to be supported with what is called mobile communication, basically. So this is basically, there are, what you have, these 5 layers of the link layer protocol. There are 5 protocols are there in the link layer. They are more responsible for everything. Now, as I told you, you have data link layer, I said. Physical layer, data link layer. Data link, these are all important, the data link layer. Next comes under what is called network layer. Basically, network layer job you know very well. It's only nothing but it is to have to link one with the other. So then that you have IPv4 you have. In that you have exhausted in 2011 and it has 32-bit address will be there. It has only 128-bit addresses are there. If you go to 6 low WIPAN, it has limited processing capability and also the data compression rate is also very low. The data compression and transport layer, you know very well, there are only 2. One is transmission control, the other is UDP. Okay, transmission control and user datagram protocols, these are all. So transmission control protocol is meant for controlling the transmission, UDP, and also you have to be aware with what type of mode that you are adapting according. And this deals with we call basically it will act like, you know, publish, use and act like a what do you call it? And these are messages are pushed by brokers and pulled by consumers. Messages are pushed by brokers and pulled by the consumer. That's what you have. So next, let us see this now. So yeah, now after telling so many things about what do you call the different protocols, because I have discussed many protocols now. So these protocols I will implement in one application. That will be the last item for my presentation. This is basically, now I am going to present the application of IoT in a drip irrigation system where I wanted to use spectral clustering with the aid of mathematics and statistics. So let us see this, how we use it. This is basically, you are going to do drip irrigation for using spectral clustering I am going to use. First I will tell what is drip irrigation, then I will tell about spectral clustering, and then I will formulate the rest of my requirement. Let's see this. For example, drip irrigation system, which is basically, it's a manual process which is needed for human interaction. If human interaction is a machine, then the entire work cannot continue there is a disadvantage of human interaction in water pumping to crops. So this I wanted to avoid. Most of the times, the water resources are wasted and they will not be available when you require exactly. So in that context, what happens, apart from this, with the aid of manual watering, sometimes what happens, the water we may pour more in quantity or less in quantity, means not in appropriate quantity. At that point also, you have to, we have to identify this disadvantage. It is not possible to provide exactly required water, and at the same time, somebody is needed to monitor the entire thing. So you can't employ all the 24 hours one person. Therefore, in this scenario, we can adapt what we call an automated system, so that the watering of any system to the crops can be effectively implemented using a concept called drip irrigation system. It will not pour in the crop, it will not pour water in the crop. Instead of pouring water, it will sprinkle. So that the water will not be wasted and less quantity of water is provided to the field of wetness to maintain in the field. Right. So this is what I said. Now let us see how we are going to introduce. Now basically, so when I wanted to introduce this, because our country, we are all dependent on agriculture. Therefore, naturally, we need to think of giving an automated solution for the farmers. So, and who are going to, put the crop, who are going to plough the field, who are going to get the crop for us. Formula, you can always design the capacity of the drip system, in which Q stands for the capacity of the drip system. VD is nothing, V suffix D is daily water requirement, what is that you require. And then T stands for irrigation time intervals, how many time intervals you require or you wanted to irrigate. Next is using water application efficiency, and T stands for duration. And then based on that, you can always calculate discharge per plant as QP using a relation called Q by N. Q by N. Q by N. QP to be a discharge per plant. N is like the N stands for number of plants. See, this is the mathematical equation that is needed while you are designing the drip irrigation system, in which it is basically the capability of the drip system and daily water requirement and irrigation interval days you require, and water application efficiency required, duration you required, discharge per plant required, and number of plants you require, how many number of plants are there. So using this, you have to design the system. When you are designing, naturally, advantages will be there, disadvantages will be there. So let us work on the advantages side and we'll go to the disadvantage later. Now, when you speak about advantages of the system, it is less requirement of irrigation water. Second is water supply at an optimal level you are going to supply. Water logging is avoided. Then it is going to produce high yield, and our irrigation is avoided. Okay. Variation in application rate and reduce the labor cost and weed control. These are the advantages. So let us see that now. Next, when you go for this, advantages of the drip irrigation system also increase in net irrigatable area. Irrigable area, it's a irrigatable area. And also high uniform distribution of water will be there with a proper control and without using much water, and controlled by using output of each nozzle and soil, each nozzle number, soil and erosion, you can avoid it. Then next is suitable for any topography. Then next is maintenance of high surface temperature, improved disease and pest control, and also it is tolerance to windy atmospheric conditions. See, what I said is, when you speak about suitability for topography, there are some fields will be having planar fields will not be there, non-planar will be there, they will not be plain, up and downs will be there. At that time, you can put the drip according to our required height, and then according to our required height and the amount of pressure that you are expected to release, accordingly you put it. Okay, all these things are advantages over the advantages of the drip irrigation system. Now let us go to the next. See, when you go for naturally, when you build a system, obviously there will be a profit as well as a loss. The loss is nothing but disadvantage. When you use disadvantage of the irrigation system, it is, of course, sometimes it may be a little expensive in the cost of constructing the system, because the requirement for large quantity of piping, filtration, equipment to clear the water. Expense, it is initial cost may be more, but overhead sometimes will be there. And then waste. See, the sun can affect the tubes used for drip irrigation and shortening their usable life as well as longevity as a variable. Then clogging. If the water is not properly filtered and the equipment properly not maintained, it can result in clogging. So therefore, drip tape causes extra cleanup costs after harvest. You will need to plan for a drip. So tape winding is required, disposal, recycling or reuse, and this method is not suitable for closely planted crops such as wheat, because all the crops are not alike. Every crop will have its own requirements. Accordingly, wheat, you can't put this in drip irrigation. So, and also the disadvantage, how are you going to measure for example, as I told you, drip irrigation systems are expensive because their requirements are large quantity of piping, filtration equipment. How are you going to trace the defect in the pipes? So myself, of course, that I will tell a later, the application, not now, immediately, because any dislocation can be known using our technology called computer-aided tomography. We use a CAT and computer. Service point of view, it is basically to design a system for all doing all these things, exercise data and make valuable decision, and then you need to take a local government, because rural market cluster analysis, we first partition the set of the data into groups based on data similarity, and then assign that labels to the groups. And then the advantage of clustering over classification is that it is adaptable to changes and help single out useful features that distinguishes among the different groups. So that's why clustering is essential. Recently, I have used this also in various applications. So clustering is process of making a group of abstract objects into classes of similar objects, and then we will use them and map them at a different situation using various algorithms. Like, I have used KNN, nearest neighborhood algorithm. Other algorithms I have used it. I will just tell them now. How to make clustering? A cluster of data objects can be treated as one group. That's what I said. While doing clustering analysis, we first partition the set of the data into groups based on their similarity, and they assign them a label, okay, to the groups for identification. Then the main advantage of clustering or classification is it is adaptable to changes and helps single out useful feature that distinguishes different groups. Right. Now, clustering in agriculture, this is clustering basically. Clustering can be adaptable in every sense. So, while we are using it in IoT and IoE, in IoE, we will use everywhere. So, therefore, one of such component I've taken, and that's why I'm telling clustering in agriculture. There are several clusters available in agriculture, which includes crop clustering, crop, you find out the crop status, and water management, pesticides, marketing, and then you have crop gain or loss or preserving warehouse. So, you have several cluster services are available. Now you have to use them and do for our application. So therefore, as I told you, clustering is it's the process of making the group of abstract objects into classes of similar objects, and then depending on how one can make the cluster, I told you, you need to what you call a cluster of data objects have to be created as a group, and then every group has to be labeled. You have to assign a label for it, and then as and when you are using it clustering over a classification, you need to classify it using the label. You have to classify, and whether it is adaptable or to change or help a single out helps out in coming out a single output or not, you have to see. So here, the most important for our computer science have used this is the I have used K means clustering. K means clustering. That means nearest neighborhood algorithm I have used it. What is this actually? Nearest neighborhood algorithm is K means clustering. Is a method of vector quantization. Was originally from a signal processing we obtained. It aims on partitioning n observations into n clusters. In each observation belongs to the cluster with the nearest mean. That is what cluster centers or cluster centroid we call it as, serving as a prototype for the vector, prototype of the cluster. This results in partitioning the data space. It helps us in what we call partitioning the data space into Voronoi cells. It is popular for cluster analysis in data mining. K means clustering will minimize within the cluster the variances. Variances of this statistical measure. There is nothing but squared in a Euclidean distances, but not regular Euclidean distances. Only squared Euclidean distances it will put with. Okay. And which would be more difficult in Weber problem, because the mean optimizes squared errors, whereas only the geometric median minimizes the Euclidean distances. Hence, for instance, like if you take Euclidean solutions can be found by using what is called K medians and K medios. You can use them. So this is basically what is called K means clustering. I'll just restate what I said. K means clustering is a method of vector quantization. It is basically originated from signal processing. Okay, that aims to partition n observations into n clusters in which each observation belongs to the cluster with the nearest mean, and it will serve as a prototype for the clustering. This results in partitioning the data space into Voronoi cells. It is popular for cluster analysis in a data mining we use it. And whereas K means clustering is basically, it minimizes within the cluster variances it emerges, but not regular geometries. It will not help, like Euclidean distances, which would be more difficult for a Weber option. Weber problem, we call it as the mean optimizes what we call squared errors, whereas the only geometric median minimizes the Euclidean distances. So accordingly, you have to do that. For instance, better Euclidean solutions can be possible only when you adapt k-means clustering, and in that k-medians you have to use it, and k-medians you have to use it. So this is a basic tool what I have used it. So let us see this now. So now after using now when you plot, this is how you got it. See, look here. So now the purpose of a nearest neighborhood algorithm or k-means clustering or k nearest neighbors is nothing but it is only objective is to adapt this KNN, means nearest neighborhood algorithm with the aid of divide and conquer, and then I will use for application. You can see this now. Objective of the KNN, it uses in a drip irrigation system is intention is to recluster it. In order to recluster the working drip points and non-working drip points, and reclustering the unused drip points into a usable drip points after repair. It is a regular process. It helps in finding pipe leakages and the repair required at a particular drip point. So therefore, the purpose of KNN is only in drip irrigation is only meant for reclustering. Okay, let's see this now. Next, our clustering on water disbursement is sprinkling in the field. There are some observations to be done. These can be done using with an IoT environment. This includes, that means everything should be controlled with a sensor environment using weather sensors, soil quality sensors, water sensors, because water pH also to maintain, and also to identify the dislocation in the pumping. Okay, in order to do all this, what we call the 4 objectives, we need to adapt IoT. That's what I said. So let us see this now. Now, water disbursement clustering. Our main observation in monitoring water disbursement plant is field. There are identifying the drip points in a good working condition, identify the drip points having leakage, and then accordingly you have to perform the what you call distribution estimate. Observation is done based on total water pumped from the source and total disbursement water diffusing of water at drip point based on what you call quantity, quantity that you require, that calculus using that relation, what I read, mathematical relation, you have to use it. And then, so now this is what you have to do. In order to do that, first what I do is, I will use one concept called our most familiar algorithm, divide and conquer. In this branch of the computer science and engineering information technology, associated with the branch among the fields are term divide and conquer. Is it something, today, the divide and conquer has become a tool for everybody to have the power. Divide and rule. That's why. Divide and conquer algorithm is a design paradigm based on the principle of recursion for multi-branch. In this algorithmic approach, algorithm designs works recursively by breaking down into the problem in hand into 2 or more sub-problems or parts. We break them to overcome from the complexity issues. The subprograms or parts are also called atoms, we call atomic, or fractions we call. These atoms are atomics or fractions are recursively broken into what we call more and more subatoms, subatomics, subfractions, until they are broken down into form of into a form that can be solved easily without any difficulty. After solving these fractions or atoms, they can again traverse back recursively, but this time instead of breaking them, we join them using one algorithm, merge sort, like merge it back. We'll use a merge sort, of course, sort I will tell later, merge. Okay, back with the recursively broken counterparts, then required solution for a particular problem is generated. Right. Now, how are you going to do this? Our intention is divide and conquer. So how are you going to use divide and how are you going to conquer? Divide, the first and the foremost process of solving any problem using divide and conquer paradigm, as suggested by the name, its function is just only meant for dividing the problem into sub-problems and then make a free complex situation and again divide to furthermore to subparts basically into example, because our intention is to adapt binary sets. We use what is called a binary set, divide and conquer approach. In that way, binary set, then the given list is broken into a single element among which then the element to sets is compared. Okay, see how we are starting divide, conquer, and then we are using sets and merging. Set sort, we are using sets and sort, but at the end we will merge it. Single element, then element of sets compared, and the user gets a prompt whether the element is the list or not. Because our intention is to use linker list and then join them, conquer, again conquer. It's a process required to conquer because this process is what we performs. The basic operation define the algorithm like, as I told you, merging there and here sorting. Sort it is. Sorting in cases of various sorts, find the element to be reached. In case of the binary set, multiplying the elements with the Katsaba algorithm. Katrabasa algorithm we will use it, but almost among algorithms, at least the most basic one that we study mostly are considered to be solved in this part, since the divided part breaks them into single elements which can be simply solved. Now, at the end, divide, conquer, and then merge them. That's it. This is the process of divide, conquer approach whose function is to recursively rebuild the original problem, but what we now get is the solution to that problem. In merge procedure, solved elements of the conquer are recursively merged. Solved elements of the conquer are recursively merged together like the way they divide in the first step, like dividing. So for that, let us use this now. So this is what you have. Yeah. Right. Babu, brightness is not there. Kindly say, I will quickly finish it. Another 5 minutes. 5 minutes. So divide and just brightness. Okay. So now, if you use the divide and conquer, the whole problem you want to solve may be too big to understand or solve at once. So therefore, we break up into smaller pieces, solve the pieces separately, and combine them, the separate pieces together. So divide and conquer is a general algorithm design paradigm. It divides this entire data input into subsets, let's say S1, S2, S3, Sn, and the total input is yes. The subdivided inputs are, disjoint subsets we call S1, S3, Sn. Then you use for recursion, we solve the problem recursively, solve the subproblems recursively, and they get solution at the end. What we do is we combine all the sub solutions for S1, S2, Sn, and then obtain what is this S. Then the base for the recursion are subproblems of constant size. Always analysis can be done using recurrence equations. You can also use recurrence equations can be used. So that's what you can use. Recurrence relations can be used. So let us see this now. Okay. Now, recurrence equation analysis, how to do this, the conquer step of the merge sort consists of merging two sorted sequences, each with n by 2 elements, and implemented by means of a doubly linked list I will use, takes at the most a bn steps I will take for some elements, some constants of b. Likewise, I will try to solve this equation as Tn is equal to b and use it. Likewise, first I will to conquer the step of merge sort consists of merging two sorted sequences, each with n by 2 elements, and implemented by means of a doubly linked list at which bn steps for some constant b. Likewise, the basis case n is less than 2 will take at b more steps, and therefore if we let Tn denote the recurring or running time for merge sort, Tn can be b for n less than 2, and Tn can be written as 2 times T of n by 2 plus bn we can write, and which can therefore be analyzed at the running time of merge sort by finding the closed form solution for this equation. So that is the solution, and Tn has only on the left hand side. Okay, right. Divide and conquer algorithm involves a spectral clustering implementation. So therefore, an algorithm divide and the control is suitable to implement drip irrigation system. It works in identifying the available water sources, existing number of drip points, requirements of that in the field of according to the sensed weather. The divide and conquer algorithm is used to divide the available water resource equally into each sub-drip point and then release water for every particular period. While providing water for the next time, the system senses the water status and takes the decision that how much water is required to support the fields. This is what is called the gist of the entire algorithm. I'll repeat what I said is, this algorithm is more suitable in order to implement the drip irrigation system because it works on identifying the available water resource, existing number of drip points, and requirement of water in the field according to the sensed weather. The divide and conquer algorithm is used to divide the entire water resources equally to each drip point and release water for a particular period while providing water for the next time. The system senses the water status and takes the decision that how effective decision can be taken there. That's how an effective management of the water that can be distributed can be taken care here. So what required to support the fields? Right. Now, this algorithm basically, there are two phases in the algorithm. The two phases in the algorithm are, first, step one, there are two stages, as you know, one is meant for dividing, the other is meant for conquering. So in that context, first let us see this. Step one, it selects the drip points available on the water sprinkling field. Second step is, it will identify drip points required water by sensing the weather status, moisture status on the field. Right. Then the third step is, it will identify available water resource in the field to supply. Okay. Then you need to divide the entire water that is available equally to every drip. Therefore, that's what I said. Apply equal water quantity in order to sprinkle from each drip point and use divide process of algorithm to divide equally the available space, available water resource. This uses only divide process of your divide and conquer. Divide process, divide and conquer. So this is only meant for distribution. Then how are you going to conquer? Let's see this. The step two, basically, it is having, then the second phase. Phase one is dividing. Then next phase two is conquering. So to conquer that, there are 6 steps are there. First, let us see one after the other. The first step is conquer the water utilized from each drip point according to the allocated water from each drip point to sprinkle. The second step is, I'll repeat. What I said is, the step one is meant for conquering the water utilized from each drip point according to the allocated water from each drip point to sprinkle. Then step two is, you need to assess the total water consumed for all drip points and compare with the quantity of water proposed to pump into the field. Then the third step is sum unit. If the sum of water pumped from the drip points is equal to the quantity pumped from the source, then the system is perfect. Otherwise, it's an imperfect system and no corrections required here. Then next step 4, if there is a difference, if there is the difference, then we can identify that there is where the seepage is, or where the leakage in the pipeline. This is an indicator that shows the status of the water utilization in the field. Then that means you need to identify the status of water utilized in the field. That is possible in the step 4. The step 5 will we can still go in depth to identify at which drip the water got assigned, in which drip at which drip point the assigned water is released and decides the preceding point. That drip point is having a leakage or seepage, because here also we use what you call something like the logic that you adapt in writing the Fibonacci sequences, we adapt. There's, previous term plus current term will give you the new term. Same thing, new status of the disk can be found. So using this simple logic, you can find it out. So that will help you to determine the dislocation of the drip or malfunctioning of the drip. You can identify it. Then a decision can be taken to repair the defective system and repair for regular functionality. This is one way. The other way is using electromagnetic theory. We will send a signal. If the signal passes through that, you can think that because electromagnetic radiations always travels in straight line.
We are having a great opportunity to listen to the words by a great knowledgeable speaker. Thank you very much, sir, for sharing your deep knowledge with us. Now, this is the time to solve our queries. Sir? Participants, kindly mark your feedback for the session 1. Let's take up again with our next technical session, which is based on natural language processing using natural language toolkits a demo. Now, I humbly invite Dr. S. Perumal, Professor, Department of Computer Science, Vistas, to introduce the chair for the second technical session.
Happy afternoon to all faculty fraternity. It gives me immense pleasure to introduce our resource person for the session, Dr. Mithun Chakravarti Janardhan, Senior Lecturer, Coordinator for Bachelor's Degree Program and Faculty of Computer Science and Multimedia, Lincoln University College, Malaysia. So he is having a record of 12 years of teaching experience and depth knowledge and discipline in computer science, and is interested in developing curriculum and participating in new interdisciplinary programs of studies. So he is much committed for the teaching faculty fraternities and has established collaboration with the educational institutions globally. So the degrees pursued by him is registered as he had done his bachelor's degree in 2005 from Bharatiyar University and 2008 Masters of Computer Application from Anna University, India, and Master of Philosophy in Computer Science in 2010 at Karpagam University, India, and he had pursued his PhD in Computer Science from Bharatiyar University, Coimbatore. So apart from that, he had certificate course in Advanced Java MTech during 2007. So the working experience says he started by 2008 and as an assistant professor in the Department of Computer Applications, Nehru College, Coimbatore. Then he had started his career as lecturer, Faculty of Computer Science and Multimedia, Lincoln University College. From that, he had been promoted as academic coordinator for Bachelors of Computer Science, Honors, Network Technology and Cyber Security. Right now, he has been serving as program coordinator for degree programs in Lincoln University College. So he's also having some research experience. The current research says load balancing cloud, security framework for big data transportation, and seismic big data handling. So likewise, the profile goes on. He had been a reviewer for the international conferences which had been held at various levels. He had more than 16 publications right now from the research, and he had also attended many workshops and conferences to point out. So he had been appointed as other proctors and academic committee members from various research institutions. So he had the membership from Data Science Association Malaysia, and he has been the member in International Association of Engineers. So he had been awarded Best Paper for 2019, and he had been produced the 100% result producer for the engineering colleges. So he had a patent which says IP Australia patent number Machine Learning Enriched Plugin and Playbook Ontology application for online e-stores. So these are the highlights of Dr. Mithun Chakravarti for this session. So over to you, sir. Mithun, sir.
Thank you. Thank you, sir. Thank you so much. Thank you for such a lengthy introduction, sir. Thank you so much. I'm honored.
Welcome. Yes.
Thank you. Thank you, all of you. Very good afternoon, good evening. I'd like to start my presentation. So let me share my screen. I think screen is shared. So, sir, madam, is my screen is shared? Can all of you see my screen?
Yes, sir. Yes, sir. Yes.
Yeah, thank you, man. Thank you, sir. So am I audible? My voice is clear, right? So shall I start? Yes. Okay, ma'am. Thank you for all of you. And let me start the session. So today I'm going to give a brief session about NLTK package in how to implement NLP. And so I think most of us who are all in here are researchers who are doing research right now and who have completed research. And those who have completed also will be having an chances of getting into the research process. And since this is an FDP program, so I would like to enhance some new tools so that we, ours as a as a teaching fraternity, we can apply all these techniques and tools in our daily life, so that that will end in the students' enhancement. Their knowledge will be enriched by having the latest techniques and tools in their hands. So that's my idea. So I will be just giving a brief discussion about NLP and NLTK, and I will show you the latest techniques and latest easy models which we have in our hands, so that we can apply and then we can do some sort of exercises so that we can show how NLTK or text mining works in our hands itself. So that's the ultimate idea. So let me get into the slide. So this is the introduction. So what we are going to do is, I'm going to start up with evaluation of human language, and I'm going to give a brief about what is text mining. Then we will have a sort of discussion how text mining and NLP has been listed in one point, why NLP comes into text mining, and I will be showing you the applications of NLP, and then we will be getting into more technical in NLP, natural language processing components, and then I will show you the packages, NLT package, which comes with Python, and I will show you a demo how to implement it. So that's my idea, so that this will enrich your I don't say knowledge, this will enrich your idea towards text mining. So text mining is, we know that this is a heavy technical process, but definitely it will be an easy step for us to get into the research, because I'm pretty sure that all of us have done feature extraction. So since those who are doing research, those who are into research, those who are starting your research, sure, either networking, data mining, or image processing, whatever the stream it be, sure you will be had done feature extraction. So this comes in the step of first step in feature extraction for preparing for formatting your data set for your research. So if you are really doing a research in text mining, then this is for you. If you are not doing a text mining research, no worry, this will be your first phase. So that's the idea. So this will help all the researchers, and this will make you aware that how we can use it. So system in handy, they can start doing it. Those who are even in mobile phones, you can try this. Even in mobile browsers, this works. I will show you a short demo as well. So now let me get into the steps. So that's the introduction about. So why we are into text mining. The purpose is, in general, we have languages. We people started to use this language as a communication medium. So now, being from India, I'm in Malaysia. So now I could able to see a lot of globally people are associated, and moreover, this pandemic prepared ourselves. Actually, this pandemic is made us more advanced, because anyhow we might have taken these tools, these online resources, maybe in the next 5 years if the pandemic has not hit us. But unfortunately, it came into our lives. So now, without any option, we wanted to take this advanced techniques and technologies immediately. So yeah, we agree that we have some difficulties in an understanding. People are still having troubles in getting cope up into the techniques. But anyhow, we will be going into there. We all started to using much better than earlier. So this is the idea. So the languages is, we know what is languages. So how the languages are made. So how it was done. Okay. Just a second. So the languages are made up of alphabets and words in form of sentences. So we know that we know as the programming languages has set of keywords and letters, normal languages also have the same. So if someone is say I'm good in English, so how you yourself make yourself good in English? The first step is we should learn alphabets. The next is form words. So we have to know the number of words. We have to learn the words of the language. Then finally, we will have a set of rules, which is nothing but grammar. So we will be learning the grammars. So then we will be, so how far, how good you are learning all these. We just say, I'm very good in this language, so I can self analyze myself how I am good in a particular language. The same scenario works out in our real, I mean, programming languages as well. So example, if you are learning Java, so one person can do a code, one person can do an application within 10 to 15 lines of code. The same can be done by another person with hundreds of lines. So the difference is because the number of words how they learn. So if I'm good in Java, I should able to use all the keywords so that I can make the program very easily and short. So that's the idea. So that makes that we have to learn the words, fine. So once is that fine only by learning the words? So the next point is we need to know the rules, how to make the sentences, like how we have the syntaxes in our programming languages. So once you are okay with your syntax, if you are having a good syntactic knowledge, if you could able to use the syntax without any error, then you are the best. So likewise, a person who could able to make the sentences in a perfect form by using a proper grammar, so he will be the good person. I mean, he can be evaluated as the best in the language. So that's the idea. So ultimately, we have the grammars as the rules. So this is what we have. So now let me take you to the next one, Mr. Matia. Recently, in a research, it is not a research. I just have made a word recently. This is not, I didn't take any proof, but I was seeing in the web that out of the whole data, so I mean, I'm getting bit into data. So out of the complete data which we use for analysis all over the world, just 21% of the data is structured data, and everything other than those are unstructured data. I think all of us know about quantitative and qualitative analysis. So either qualitative or qualitative, please don't mix with here structure and unstructure, because either it is qualitative or quantitative, that is termed as structured data. The one which you couldn't able to identify what type of data it is, even it is not a mixed data, you couldn't even able to, how can we categorize this data? Either this is a structured data or unstructured data. So that will be our unstructured data. So that which you cannot name it as a qualitative or quantitative. So those are unstructured data. Means where you will find those data. I think most of you are using, not most of you, all of us are using smartphones, and people are using smartphones in our own way. So the way you speak your own language, the way I speak my own language will be different. Means, I think, for example, okay, today I'm going to monitor your activities. Example, take our head of the department, sir, so who was speaking with me, Dr. Mr. Permal. So imagine that I'm going to track his mobile phone, I'm going to track his WhatsApp account. So whatever he types, I'm going to scan, I'm going to do some analysis, I'm going to take all the text and I'm going to implement into my algorithm, and I'm going to see what he has spoken, to whom he has spoken. So in that case, he must have written in a proper language. In case if he has written in Tamil, fine. If purely Tamil is fine. So Tamil, again, I will take Tamil. But I see there is a form of Tanglish. People used to type Tamil language in English letters. So in case it doesn't have any grammar, by alphabet, I mean that the system understands that this is English. When it gets starting analysis, the system gets understood that this is not English, this is not right grammar, this is something else. So there we are struck. So that is called unstructured data. If we take such data, even it is in the form of text, if you take those set of text for analysis, now I just said only text. Imagine that I want to take his pictures and I want to do some analysis. Then the picture should be in the picture format. So it should not be in another format. The picture should be clear what it is going to show me. So that those items are unstructured data. Now people are using all over the world, I think millions. So I think people are going to discuss about big data as well. So they will be covering up how big data is. So we have lot of data. So normal traditional database systems never work. So for those, so we need to have something else. So something else is big data. So that's the process. So I think you got understood. I think I had made a point what is structured and unstructured data. So now I will take you to the next one. So this is what I was discussing. So this big the languages. So now the next point is why text mining comes in here. So okay, fine. So we know programming language, we know some languages. So what is the purpose of it? So straight away I can do some analysis. So where it comes text mining is, the purpose of text mining comes into here is, since we have a large amount of data, we need to know many important aspects from the text. Example, what I speak, am I speaking a sense? People, those who are attending the session will be listening, and they say that we always have a review. Okay, this guy takes my time. This guy gives a good information to me. So we have such impacts. So you yourself, your brain analyzes that whether I'm speaking sense or not. So that analysis, it is taking your time, not me, but your analysis takes your time. So we replace a technique over there to make such analysis. That's called text mining. Either I speak, I send something to you in text, whether I write, whether I publish, whether I write an article, whether I speak with you, whether I sing, whatever it may be, I'm going to use some language, either English, Tamil, Hindi, Marathi, whatever it may be. I'm going to speak with you. So that language must be analyzed whether we are making sense or not, whether that information is going to be used for me. Okay, today I'm talking to you, all of you, one-to-one, maybe one-to-many, but I'm directly coming to your steps. Imagine that I'm not connected to with you. You are watching my YouTube channels. So then you have to listen completely, then you have to understand, and then you have to know, okay, this gives me some information. Imagine that after taking 1 hour of lecture, I'm not going to give a good information to you. Then you just feel that, oh, my time has been wasted. So that is the lacking. So we need a person who says that, okay, this guy is presenting, hey, this gives a good information to you. You can listen him. So there should be one representative who will assist us. So that's who is text mining. It analyzes whatever I speak, whatever I type, then it gives me an information that this is something relevant to you so that you can learn. That's what we are facing in our advertisements, in our whatever you see in applications, or in your YouTubes, or in Facebook, or even in your email accounts. So just try something in your Google for 2-3 days. Just try good hotels in Manali, good hotels in Mumbai, or something like that. The third day, then immediately after 1 or 2 hours, you will get all sort of hotels offers in related to the accommodations in Manali and Mumbai. So that is also text mining. So someone is assisting us all the way by the means of text we use. In case, don't worry, I mean, I'm not also mentioning, I'm not only meaning the Google, I mean, you search in Google, just make a call to me in WhatsApp. You just speak about something. Hey, I would like to come to Malaysia. I want to stay there for 1 or 2 weeks. I want to go to Genting. I want to go to Penang, or I want to take a tour to Malacca or something like that. You just say, and you just ask me what are the offers you have, hotels. Can you assist me in booking the hotels or something like that? The next 2-3 hours, you will get automatic messages, automatic advertisements in your inbox. So your WhatsApp is connected to Facebook, your Facebook is connected to your Gmail is connected to your, again, to your other applications in your system. Then wherever it goes, the data gets synchronized, everyone is allowed their authentications, everyone are connected, and they are assisting us all the way you have text mining with there. So this is the process of text mining. It derives, okay, initially when you call me, you won't ask me straight away, hey Midun, I want to book a hotel in Malaga. No, you will just introduce yourself. You'll say, how are you, how is pandemic over there, how are you, how is your family, how long you have been there. You'll be talking all the formality informations. Then you will come to the point, you want to travel in Malaysia and you want to have book hotels in Malaysia. So then this system will retrieve only those required meaningful information. So all the text which you spoken to me will be taken, and some information will be given to the airlines because you want to book tickets. Some information will be given to the travel agencies for booking visas. Some information will be provided to the hotels in Malaysian agencies. So then this text will be analyzed. Whoever is there, their informations will be analyzed, their informations will be retrieved, their meaningful informations will be retrieved and provided to those stakeholders. So that's the work of all these applications. That's the reason why all these applications are synchronized. So this is one set of example I just given. A lot of examples over there. If you get into text mining exclusively, you will learn all those. So this is what I was dealing about. So when you search, it will take you to the ultimate goal is, the overall goal is essential to turn text into data for analysis. So whatever we speak, whatever we read, whatever we type, whatever we search, all those information, we may not use proper English, we may not use proper spellings. If you take me, I'm very worst in making spelling errors. So if people are there, and people won't give the meaning, even if we are very good, but we will be searching with keywords in Google, we will be searching with keywords in YouTube, then we need the informations. All those are turning, the process of turning, turning a not meaningful words into a meaningful words, turning a complete brief information into a short information which can be easily analyzed. So only the essentials words will be retrieved and taken for analysis. That is the process of natural language processing. So whatever we speak here, example, I'm just speaking from Malaysia to you. So imagine that if I keep on speaking about some bomb blast, how to make some machine guns and AK-47 or gunpowder or something, immediately I will be trapped. I will be caught by police. So people will be analyzing. So all these words, I think network people are here. If something is vulnerable, if something, the text is highlighting with some unusual words, immediately it will be informed to the respective people. So then I will be caught. So that is also common. So in there also, that's why people used to say, oh, my WhatsApp has been taken by someone, my WhatsApp data has been recorded. I think most of VIPs have those problems. So if you want to become a VIP, you can also try that. You just talk something about gunpowder, explosion, guns, bombs, then you will be caught. So that's the idea. So all those information will be taken. That information, that taking the required information from you is called natural language processing. Then it goes into several steps. So I will take you to the steps of NLP. I think those who are well versed in NLP, please bear some time with me. I will take you to the demo. So then that will be a new process for you. For those who are already know what is NLP, yeah, fine. Please have some time. So natural language processing is a part of computer science, AI, which deals with human languages. That's what I was speaking all about now. So we have artificial intelligence. We know what is artificial intelligence, which again, the key point, you can make a point that who will assist us. So the who will assist us, in that part, we are going to concern our language as well. So then the text mining comes in. To implement text mining, NLP is there. So this is the process. So initially we started with computer science, then we wanted to have, first we started calculating, then we wanted to store our data in our system, then we thought of sharing whatever data we stored in our system to others. So then networking came in. So networking was there, calculation was there, storage was there. Now the problem is how to make very speed and effective all these processes. Then we wanted AI. So AI came in, then we started doing it. AI supports us in many streams, we know. So in that one particular point is, it also assists us in human languages, because all of you know that all of you might have at least used at least once the translators. So we have translation softwares, translator applications, where our human languages have been translated immediately by the system. So also there AI works. And researchers, I think you might have used Grammarly, you might used rewriting phrases, Quillbot and Spinbot and etc, etc, etc. So we used to try all sort of rewriting phrases, right? So all the where AI works with NLP. So in hidden, it works there. So let me take you to the next one. So NLP applications, just now I was also saying the same. So sentiment analysis, chatbot, hello, speech recognition, spell checking, keyword search, machine translations, information extracting from the website. I think people who are doing review, sentiment analysis, they will also might have used information extraction. The word exact technique is web crawler. So those who are using web crawlers, so that's nothing but information extraction from the web. So these are some of the applications you might have used. Keyword search is, everyone knows. Advertisement matching, that's what I was explaining now. And chatbot is there. Hello, speech recognition. Yes, many applications are there. Still, you will have some more applications as well. So these are natural language processing applications. So, okay, fine. We know these languages, how it works. So the components are, there are two components. One is natural language understanding and natural language generation. Okay, now, so let me take you back to the previous slide. So until here, NLP applications, what we have discussed is just only the introduction about to get all of you into the process. So I wanted to make all of you turn to my side and to see what I'm speaking about. So what I speak is about NLP applications, and where the NLP comes in, which is text mining. So what is text mining? The assisting people in the means of using the texts. So what are the applications? And this is what my background. So to here, we are going to, on this area, we are going to discuss something. So which all our researchers, professors, dignitaries can get some idea about natural language processing. Then it shall be transferred to your students. So that's the purpose of FDP, I think so. So now I take you to the next slide, where our real component works on. So NLP components. So what is the first step to get understand technically? So what need to be understood, and how we should start, and from where we should start. So first, if you are ready to do some natural language processing, technically, when you open a system and you sit in a computer and you want to do natural language processing, first you should know what language you are taking off. You can also take any language, no issues. You can take your own language also, but it has some extent, you will have some problems, then you will need to have some technical assistance, that's it. But you can do your own languages as well, even you can try in Tamil as well. So now let me get the idea. So natural language understanding. So first we have to understand the language. In understanding the language, the most important point is whether the given text is written in proper words, and whether the text which used in this language is in proper sentences, whether they have used proper grammars. Then we need to get our next component, which is natural language generation. So what we are going to do in here is, we are going to create a synonym dictionary. I think researchers might have heard about the word synonym dictionary. So what we will do is, most technical was a lexicon, many things are there. We will see few. So natural language understanding, first you should have an idea about what is the language. Then from there, we are going to take a sort of good informations, the meaningful words, and we are going to make as a separate dictionary, which is natural language generation. So this one is already there. We don't need to create a new one because already people have done. In case if you are doing a specific research, example, if you go to Google for researchers, I'm making this point. If if you are using Python for making your research analysis, if you are doing some text mining processing here, you want to analyze how these texts are used. Then, if you search for some specific, if your background of research is in health science, particularly about a particular disease, and if you search for those type of words, you may not able to focus. You may not able to find. In that case, you can create your own dictionary. That's the idea. So for that, first you should be very clear what are the words should be added in your lexicon, or it should be added in your synonym dictionary. So that creates your natural language generation. Then you can use it for that. So that is heavy technically, but as we all are academic researchers, those who are technical and scientific research, please forgive me. So this idea is, I just say, for academic researchers. If you are technical researchers, then no other go. You have to create your own natural language generation. You should create your own dictionary. That's the only point. Now, what is the process in here is, first we need to identify what are the input useful representations used in your language. So you mean I'm now, for example, I'm going to do a research. I'm going to use only English, but I'm going to work on specific. I need only the words related to medicine or hospital. I mean something medicine or disease or something, a specific disease analysis or something like that. I need to take only those important words, and I should understand. I should analyze what are the words to be used in here, or something like that, which doesn't comes into the grammar part. So those will be analyzed. So these two will be separated in here, and finally we'll be creating the chunks. Chunks are the data sets. I think all of you might have used CSV files or text files for your data analysis. So here we shall be able to prepare our chunk grouping, splitting our document, huge data set into small parts. So now let me take you to the next slide. So this is what I was saying you. So let me take you to the concept. Yes. First, tokenization. Tokenization is the first step in NLP. Okay, before that, am I clear? Is that audible? You can see the screen, right?
Yes, sir.
Yeah, thank you. Thank you. So now let me take you to tokenization. Tokenization is the first step in NLP. So first, we are going to start up with tokenization. Once you give the sentences, once you give the text which you find in your system or in your data set, if you have a paragraphs or a set of data, you just give, then imagine that this is the data. Tokenization is the first step in NLP. The output of tokenization will be this. So it will be splitting up the words like this. I think researchers might have already used this. Please take some time to just have a refresher. Soon we'll be moving to the technical part. So tokenization is the first step in NLP. All those words will be separated. The complete sentence will be separated into words. So that's the work of tokenization. Okay, once tokenized, once the word is tokenized, then we move on to stemming process. So here the stemming process will give the root word of the information. Okay, here you might have seen affection, affects, affections, affected, affection, affecting. The root word is affect. So whatever term with adjectives, with continuous tense or tense, whatever you give, so it will take, it will analyze, it will retrieve only the root word. So first step, your complete text will be splitted into single word. And for those words, those repeated words or those words it has been there, so that will be identifying only the root word. So everything affects, right? So it gives the root information what you're going to say. So what is your ideology? You say that this affects me a lot, this is affecting me a lot, this affected me a lot. So whatever term you use, ultimately your impact about that incident or that sweet or that food or that incident, whatever it may be, that has affected you. That affect is what the root word. So this gives the real meaningful word about the whole sentence. So that's what we do in stemming. Again, lemmatization is the same process, but here, in case if you are using large amount of data, so group together different inflected forms of word, which means that if you in case you may have a problem that in stemming it may not work in some cases. Some cases you may wanted to also know about, is that current tense or it is past tense, is that affected or affecting, or still it is you are not okay with that or something like that. In such cases we will be going for lemmatization. It takes each one word as the root word. So here all this gone, going, went. So went is also considered as go in here. So when you take the output, everything will be tracked into here. So finally we will be lemmatizing in the process and we will be finding out the root word in here. So that's what lemmatization does in here. And finally PO stacks, where the grammar part comes in. So what we do in here is we take the words and we just give the grammar tags. So here you can see the dog, I think the dog killed the bat. So this is, I don't know, noun is here, verb, adjective, I think so, DT. So it goes like that. So those who are very good in grammar, please take note. I'm not good in there, but I know N is noun, verb, and it takes you it gives the tags for each word. So first, the tokenizer makes your word into separate words. Then next part, we are applying stemming process. Then you will be making the PO stacks. So your words will be given some with verbs. So then I take you to the next one. Google something on the internet. That's what we do. Oh, sorry, I think the one example is missing. Yeah. Yeah, I had an example in here mentioning the nouns. So Google was noun, something was verb, on was AD and DT, and thus DT and internet again DT. So that's the idea. Internet is also noun, I think so. So here the example was there, it's missing. So I'll take you to the next one. Finally, the next step is NER, name entity. So now it gives the values of the words, monetary value, organization, location. So first part, PO tags, just gives the tags for the verb in grammar part. So here you can see an example I have. Yes. Google's CEO Sundar Pichai introduced the new Pixel 3 at New York Central Mall. So when you apply NER into your Python and then you apply NER, so it clearly mentions Google is not a noun, it's an organization. Sundar Pichai is again not a noun, it's a person. And New York is a location, Central Mall is an organization. So this will be also tagged with that. So now, again, I will come from the beginning. So first we are sending only one single paragraph and we are tokenizing it. Then we are performing the stemming and lemmatization. So once we do, means that we take the root words. If you want, you can also use all the words which you have. I will show an example like that. And then we will be applying our PO tags. So all those words related to grammatical parts will be tagged with grammar values, and the words which is not grammatic and which is something related to name entity recognition like organization, person, location, money, whatever, many things are there. So those will be also tagged with this. Now we have group of words. We have nouns, we have adjectives, we'll be having verbs, we have organizations, we have persons, we have locations. So all these are separate groups. So that's what we call it as chunks. So chunks, picking up an individual piece of information, grouping into the bigger piece. So that's what we do in chunking. So now you will have the text format, text files or CSV files. Now you can take for your analysis. So you can apply all your, now we have made a data set for your analysis. That's what text mining does for us. So text mining performs creates the meaningful data database or synonym dictionary for your analysis. So now let me show you okay, here is a chunk. So all those nouns will be separated, name tags will be separated, and name tags will be separated and be listed. So this is how we do the process. Now let me take you to the next step. So technically, how to implement this? The technical part in implementing NLP is, so whatever we saw, all those steps starting from tokenization to chunking, it can be easily implemented using Python. In Python, we have the package called NLTK, which is Natural Language Toolkit. So it comes from Python. We can use this NLP Python NLTK package to implement your text mining process, particularly NLP, natural language processing, can be done. So I will show the code here. If I can take some more time, 15 to 20 minutes, I can show you a good example. All of you can also make work. Shall I?
Sure, sir.
Yeah. Okay then. So in case, yeah, please. So those who are in computers, those who are having, so what I have done is I will show in one glance and I will show you a real-time example. So what I have done is first I have imported NLT package into my Python library. You can see import OS, import NLTK, import corpus. I have imported all the corpora. Corpora is nothing but the data sets. You can see all the zip files are there. Plenty of data sets are there, not plenty, huge heterogeneous data set. It grows daily basis, minute by minute. You can see also Twitter samples also here. Twitter, you will have everything in Python. You can use all the data sets for your text analysis. You can see Indian zips are there, and a lot of all the bank zips, even ABC, and a lot of data is there. So you can also go for all types of corpus. So you'll get all sort of data sets in here. That's an example here. So let me take you to the first step of, oh, sorry. I think something is missing. Mistakenly, I typed somewhere. Sorry. Yeah. So the step is, first step, I will show how to make the tokenization. So I will take you to here. Okay. So what I did is I have created a variable. AI is the variable, and I have placed the paragraph in here, and I have just listed out, and I have incorporated tokenizer into my program. Word tokenize method. So NLTK tokenize is a package, and in there I have word tokenizer method, which will tokenize the word. So this is how it does. You can see the whole paragraph is in here, and what I did is from NLTK tokenize import word tokenize, and this is the token. Word tokenize is a method. I put the variable in here AI, and I display AI tokens. Just like that, it has been tokenized. So the complete paragraph has been tokenized in here. So let me take you to the real example. And those who are in computers, those who are, I think all of you can see my screen, right? So those who are in computers, those who are in mobile phones also can try this. And I will show what a Colab is. So this is Collaboratory Lab, Google Collaboratory Lab, where you can we can write your Python code directly. I think maybe some of you might have used. So those who are not aware of Colab, you just try this. I just typed Colab in Google, and it will take me to here. So I just give a sample here, document files. So I have created a name and new notebook. So this will take me to my new Python program environment. So this takes me to there. So this is where my one is. So I can name it here, and this is where I need to start doing my coding. So I will show a simple example to make Python code to make the text mining process in here. So first step, I need to, those who are following me, please try this. It is very simple. You just type Colab in Google, just click on there, you'll be taken to this window. And those who are even Android or those who are in iPhone, they can also try in your browser. You can use in Safari, you can use Opera, whatever web browser you have, you can try this. So no need to implement, no need to install any new softwares. Just like that, you can do the Python code for text mining. So import NLTK. So what I did is I'm importing NLT package into my system. So I have imported. So that's it. So it will be taking a few seconds of time. It will be loaded. So then it will be imported into my process. So when you use Colab, particularly Colab, Google Collaboratory Lab in your Python code for text mining, then you need to write one more, import one more item needed to be downloaded. For that, I need to just click on code and then just click on here and type NLTK dot download and then open the bracket and just type NTK package. So I just give PUNKT. PUNKT. So this is the package. So I just want to download this. So then once you click on, you can see it downloads. So now you are ready to do the process of text mining. Let me take some example from the websites. So I was also looking into some data in here in Will's website. So let me take a single line or about university data. So what I do, I was searching for some data from your website. Let me take some real-time data. Okay, I just take some information from profile. Okay, let us do text mining on the data in here. Okay, let us take the data in here. So the university was formed in something like that. So I just copy this. So this is going to be my text data. People who are following me can also do this. So what I did is I have taken the data from here. I'm getting into here. Now I'm going to create a new variable. I just click on code in here. So we are going to create a variable, a string variable. So in Python, it is very simple. So I just type text or text1. Text1 is the variable. Okay. Now I'm going to paste the paragraph which I copied from there. So just like that, I have copied and I'm running this code. Okay. So I have run this code, which means that the variable text have the complete paragraph. Let us try whether it has been already working. So I just type text and run. Oh, I think text1, I think the name. Text1, yeah. Text1 was the variable I have created. So I'm just running. So this is the text. So what we have copied from here. So now what we are going to do is we are going to tokenize this paragraph. So for that, I just click back on code. For making tokenization, first we need to import the word tokenization. So from NLTK dot, it will come with tokenize. So you can try, those who are following me, please do exactly the same. So what I did, I am just downloading, I'm going to import a function called word tokenizer from tokenizing function. So NLTK tokenize, from there I'm going to import, just type word, it will come. So this is the function which we have already over there. So what I did, I have created a variable text1 and this is the paragraph I have taken from there and I am just importing the tokenizer into my function. So now I have imported. So word tokenizer will work in my program now. So let us tokenize. So once we do tokenize, all those tokenized words should be stored in another word, right? For that, I just give token1 or tokens1 because many words will be there. Tokens1, I just give equals. This time I need this function to be incorporated, word tokenizer. So word tokenize. So this is the function. And inside the function, we should mention this text1 because which is our paragraph. So now we can see what I did is I have created a text, I have created a variable text 1. I have assigned the complete paragraph from your website, and that is the information. So text 1 is there, and then I have incorporated tokenizer to word tokenizer in here. Tokens 1, word tokenizer, text 1 is there. Just execute, the tokens 1 will be there. So now all those words have been tokenized. To have a look, what we can do is we can just go back code, or you can also write there itself. You can type tokens 1, or you can also type as print 1. If it is error, we have to, okay, it's not error. You can see now we have made the tokenization. The complete paragraph has been splitted into single words. So this is the process of tokenizing. So that's what we did also in here. So what I did is the same we were following. We have created a variable and we have assigned the complete paragraph, and we have used the tokenizer and we have tokenized the complete paragraph. So this is what I did now. So now let's move to the next one. So here there are some probabilities they are checking. They are checking the length of the tokens. They are checking the probability. What I did in the previous exercise, I used to show this exercise if I'm not allowed to do the technical part. So let me show you this as well. Okay. For this, again, we are going to do some frequency distribution. So that's why we call, first let us have a look on length of our tokens so that we will have an understanding how, okay, tokens. So the number of tokens are 74. So this paragraph contains 74 characters. So this paragraph contains 74 characters. So that's what in here. So let me take you to the frequency distribution. So let's have a look what are the top 10 words or something like that. For that, first we need to go for from NLTK and just click on probability. It comes in, just click on for probability and go for import and type frequency distribution, you will come. So those who are following in mobile phone, I think you will also get the same. So frequency, oh sorry, I did a mistake in here. Now I have incorporated the frequency distribution. So now I need to create a variable for this. I need to create an object for this method. So this is a method I have imported into my program where it comes from this probability package. So I just go back to code again. I just incorporate a new object. An object, I just say FQ is my new object. I just incorporate, I just refer the function in here, frequency distribution. So this I do in here. So FQ is my value. So now I'm going to do some process of analyzing the tokens. So we have the tokens. Let us have a look on how many words and what are the words and what is the frequency of the words. So let me go for how many numbers of times they have used. So I just go for code again. I just type for word in tokens. So I think tokens 1. Yeah, tokens 1. And then, so this is a loop I'm using. So I just type FQ. And I go with word. So word dot lower. So what I want to have in here is I want what are the number of times of each word used in here. So that gives me the data. So words of the data. So I just use FQ. Now, if I execute this, I will get the words used in here. So you think positive, apostrophe S's once and commas 3 times, full stops 4 times, aims 1, and you can see has 2 times, India once, off 5 times, president or chancellor once. So like this, we will be getting the words. So in these 73 words, it has been mentioned like this. So this is how we do the process of making the tokenization and then counting. So you can also make other distribution, top 10, so like that. So what are the top 10? I think here top 10 won't be the right one because most of the words are 3 and comma and 5. So 6 will be the top worst. So we can also list it by using most common function. So this is the process of tokenization. I will show the process and see. So fine. So here, if you want to have the top 10, I will share this slide. You can also take note of this code. So here, top 10, this is a variable, frequency distribution, top 10, and this is the function, most common. If you take with first 10 or first 5 or first 3, so it will list out which are the words comes in the top 10 frequencies. So this is how we apply tokenization. So there are this is how we tokenize. So now we have made the tokenized process. Let me take you to the stemming process. So here we are going to do some stemming. So I have in the picture, you can see in this slide, you can see there are two types of stemming process. One is Porter stemming and Lancaster stemming. So it is up to you. You can use any of these stemming process. So it comes with your own wish. So I don't go with much about the again iterative process of having multiple. I will show some examples in here process. So I just go code and see the stemming process. Also we need to incorporate nltk.stem import Porter stemmer. So Porter stemmer is a one function, and also we have some other stemmers, Lancaster stemmer. So I just first show you the Porter stemmer. So for that, I just again go with from nltk.stem and then import. So the best part in here is you can also try this in your own what do you say, in your own mobile phones also. So that is the most important aspect in here. So so I have incorporated the Porter stemmer into my code. You can also make it in one single code function, but I make it multiple because it can be very clear for you. So now, so we have done this, so you can have a look over there also. So here see, we have imported Porter stemmer. Now we are going to create an object like this. So PSD is an object here for this Porter stemmer. So what I do, I just create an object. So this time I just create PS. So I just clean equals to, and then Porter stemmer. So Porter stemmer is a method which is brought into here, and PS is our object. So now we have created an object. Now we can go for our stemming process directly. So for getting the stemming process, you can see here they have used some words like, here, let me take you to the words. So here they are using having and have is the word. So let me take you to some other words which we have in our own paragraph. So what I do, I just give a code in here. This time, sorry, ps dot stem. So stem must be the process. So you can see ps dot stem, and then we need to give the words. So what are the words we are going to do is, let us take some words in here. So visualizes. That is a good word. So this is a word which I have used. You can see it stems out the word. Visualizes, visual. So I will also take some other word from the paragraph in here. Chairman conferred. You can also make a right click and copy selection, or you can use Control C and V. I just show you the other word. Conferred. Confer. So this is the process of stemming. So it will find out the root word. It is very simple to apply stemmers. That's all. So you just incorporate NLTK stemming process, and you just incorporate the Porter stemmer or Lancaster stemmer. I have shown in the picture over there. You can try that. I don't take much time in that, repeating the same. So I have incorporated an object. I have created an object PS, and I'm incorporating the stem process, and I'm using the words. You can also use the complete words, no issues. So it will list out the root words of the words which you have mentioned. So that's the idea in here. Okay, I will also show you multiple, how to use multiple. So visualizes this time. Will get done. Oh, sorry, it doesn't work for, I have to create tokens and then I have to use it. So I cannot use directly if I'm using. So in case if I want to do that, I have to create a variable and I have to import that variable. The variable should have all the words and I have to use it. So that's the next part. So this is how we use Timber. So I just visualize in here again and make try on that. And in case if you are okay, I understand that most of you might be very new for using in Colab with Python. So in case if you get error, okay, example, if I am getting an error, like if you see here, so I will be getting an error now. If I get an error, so what you can do is you can just click on search Stack Overflow. They will assist you in rectifying your errors. They will say what is the error, and they will assist you in identifying the process to be resolved, and they will help you in resolving your problem. So this is how we do stemming process. Now, what we have done is first we have done tokenization and stemming. Now stemming is done, and now let me take you to the lemmatization. Okay, I don't repeat lemmatization. Straight away I take you to the next process, because lemmatization is again the same similar process. If not, I will also try that. So from NLTK, stem, import WordNet and WordNet Lammatizer. So this is the new function, Lammatizer. So Lammatizer should be there. So there you can see give is there. I mean, there all giving, given, gave, everything will be give. So here the root words will be the exact word, so that you can store the exact words into your data set. If you don't want to have the multiple, if you don't want to have the root word, so that you will be missing the general words. So in such case, it is very similar, both stemming and lemmatization, but now most of them are skipping the process of stemming. They just use stemming only for removing the stop words, then they start using lemmatization. So lemmatization is the best part, so that you won't lose the meaningful data. In case where there are chances in stemming process you may lose data, but stemming helps us in removing the stop words, because you might have noticed the stop words will be removed. So only few words, the words which is really meaningful will be there. Imagine if I give a full stop in stemming process, nothing will be turned out. So the words which has some meaningful root words will be there. So then once the stemming process has been applied, all the unwanted words which will this there full stop comma, everything will be removed from here. You will be having only the words which is really have some meaningful terms. But when you use only stemming process, there are possibilities of missing the words of visual, the words, root words. So in that case, you will be using lemmatization. Simple, the same, both lemmatization and stemming process will be applied exactly similar. Now I take you to the next one, because I think I'm taking time. Sorry, I'm taking much time, I think so. So I'll show you what is the next process. Here they have created, okay, I just didn't mention you, TOS tags. So which means that grammatical terms. So again, this is a simple technique, how to give the give the tags for the grammatical words in your data. So here cent is a variable, Timothy is natural when it comes to drawing, and cent tokens, we are tokenizing the word, and then for token in cent tokens is they are applying TOS tokens. So if okay, I will try that, so that I will show you. Again, I just give text 2 because this is much pretty important. So text 2 is a variable. I take only one sentence from here. Okay, I'll take some other sentence from okay, just take this one. Yeah. So text 2 has some value. So to get the text 2, I just type. So this is the variable. So this is the value. So now we need to tokenize this first, and then we need to import we need to apply the POS tags. For that, let me get into the code. So here for getting, first I should get the tokens, right? So for that, text 2 underscore token. So I'm going to tokenize this word, this complete paragraph, this complete line, and I just give word tokenizer, which I have already incorporated. So word tokenize, and then I'm going to use this. So this is text2. So we have tokenized. So now text2 has been already tokenized. To get the POS tags, this is much important. We need to have some more downloads. So first we need to have NLTK download stop words. So stop words must be removed from here because we should not use the stop words. So that doesn't comes in our stemming process. Means that doesn't comes our POS tags. So I just have stop words. Then we go with NLTK dot download. So this is because I'm using CodeLab. If you are using some versions of, if you are using your own Python libraries like Jupyter, or so there you may not need to have all these. So this one, since I'm using page by page of document, so I need to have, and this is very simple so that you can, you can show the illustrations to your students directly by applying all these analysis. And even if you're not using text mining, you can also use Python code directly. So here I'm going to use averaged perceptron tagger, so which performs the perceptron algorithm. So you can try for tagging the POS tags, for tagging the part of speeches. So let me check the spelling. Averaged perceptron tagger. Yes, I think so. I'm correct. So first let me download all those. So I have downloaded, that's it. So now let us do the code for text2. So we have created a text2, which I have taken this line and I have already tokenized. So if I display this, it will be listing the tokens. So I don't want to have the token. Straight away I go with the POS text. So for, let's say token, token in text token, this word, this should be the word. So here I'm going to search for the tokens. Text2 token. So here is where we are going to search for the tags. So then I'm going to print the tag words. So now if I incorporate nltk.pos, you will find, okay, I will show that. You can see POS tag, part of speech tag. So this is because only if I download the stop words and average perceptron, this POS tags comes in. So I just go with token. The tokens will be displayed. So this is a just print function, which means that I'm going to tag the words in here. So I will show again. I have created a variable in here. You can see this is where I created the variable, and I have displayed the variable in here, and I have tokenized. Again, I did the tokenization, and then straight away I move on. I didn't do the stemming process. Since this is only one single or two line sentence, I want to have the POS tags. So if I do the POS tags like this, it will be listed. John, noun, is verb, eating verb, I don't know that. Delicious, again, cake, noun. So like that, I will get the output. So let me check this. If I'm okay, yes, it works. You can see that it proverb, or it is verb, adjective, pleasure, noun. So it goes on like Vistas, I think Institute of Science and Technology, I think so. Noun, presence, nouns, continuation, compilation. So it gives the grammatical terms in here. So now the complete sentence have been tagged with the grammatical parts. So this is how we apply POS tags. So it's very simple to do this. But since, as I said, you can also try this in your in-hand process itself. You can try in your mobile phones, you can system, anywhere. You can straight away implement and you can do this. So this is how we do it. So now we have done with the stemming from in POS tags as well. Finally, NER. So name entity token. So again, I will show the name entity token. Again, I need to install something else. Okay, first let me narrate in here. So once you do the name entity. So then, as I said, I was discussing with an example for Google CEO Sundar Pichai was launching a new product in Central Mall. So all those have been mentioned. So here also you can see the US president stays in White House. So it's a grammatical word, organization. So here US has been, US has been mentioned as organization. President stays in facility. White House is a location. So even it isn't mentioned as location, it says that it is a facility. So it goes like that. So this is how the the process of NER works. So it gives the process. So now once we do all these segregations, once we do these groups, okay, these words are groups. Now you can have an understanding that the outputs in here, okay, I will show this. The outputs in here, it can be directly taken into your analysis process because it clearly comes up with the commas and also with single quotes. So whenever it comes, you can segregate these are your common attribute values and you can pass into your analysis. So take only nouns. So if you want to say your algorithm to take only the nouns, you can just mention as NN. So then the data analyst will analyze only these words in here. So you can prepare so now the data set is ready for you in several groups, in the form of names, in the form of organization, in the form of your text words, and it is ready for analysis and you can try directly. So that's what we do in here in chunking. So chunking means we ourselves prepare the groups. So we prepare our results. You can just, but now it is simple that you can, when you use Colab, when I have done the process. So for this word I have made, if I want, I can also go for the next one, NER. Okay, let me do the NER also for here. So I think for NLTK, I just mentioned as, I think I need to import few things. I just NLTK download, just go with the words because I'm going to use words. And then I'm going to download, I think Max Chunker, I have already, no. So I need to import Chunker. Okay. NLTK Max Chunker. Okay. So only for those who are applying directly the chunking process, you have to download all these. Else, you may not need it to have all these. So here I just give max and also no worries if you have not downloaded. If you have not downloaded, it will be mentioning you. So the error part will say you what is missing over there, and you can directly download by using the code. The code will be also mentioned over there. I know people who are using research right in currently they are very new for Python Colab, so no worries. So this MaxNet new NE chunker, name entity chunker, is a new package I have downloaded. I'm going to download in here. So only upon downloading words and only upon using MaxNet new chunker, I can do the process. With this, I also need some other algorithms. So what I need to do is NLTK. I need to go for from NLTK. This time I just type chunk, NLTK chunk. So I'm going to do some chunking process. Import. This is simple. CONLL. You will get the options in here. So just try. Just give a comma. So these are all chunking process. It will create your groups. So that's the point. So I just give 3 chunks also. And you can see here. Thanks. So what I did is I just incorporated these 2 chunks in here. With this, I'm going to use okay, one more NLTK dot chunk. This time I just import NER chunk, so that I can use the name entity as well. NE chunk. So I am going to show you the name entity. That's it. Sorry, I think I'm taking your time. Sorry for that. So I have incorporated these 2, and yeah, fine. I think pivot stacks already I have done. Okay, fine. Let me download all these. Then I go for the text. It's getting downloaded. Yes, done. So now I go with the code. Let me take the same code. So same code in here. The words which we have done, pivot tag in here. So the same code. Let us also take the same exact code in here. No fine in here. So text2 is our value. So for that, let me create a name entity tree. Ne. This is our own variable. So our own object we are creating. I just give ne. That's it, name entity. And then I go with ne chunk. So chunk is the function which we have downloaded from him, which we have incorporated in here. This is the function I have incorporated the object in here. So now I need to go with the process. So first I go with pivot stack. Okay. Still it is not being incorporated, it seems. Any chunk, pivot stack, okay, fine. Then I go with word tokenizer. Tokenizer, and this time I'm going to give the text which we have already created now recently. So text2 is the word here. Text2 is the one. So for this, I think I have an error. I think so. Let us see, or else I need to incorporate one more. Let me try that. Just go and import LTK chunk. Now I think don't need, because this pivot stack must be there for chunks. It may not affect. So now what I have done is I have created a chunk. I'm going to create a group, and I have imported NLT chunk, and this is the variable we have incorporated into here. And then we are importing pivot stack because we are using pivot stacks as well. So now what we have done is we have created a new object. Ne is my value, where it is going to have the values of these functions. So text2 is the value I'm passing in. The text2 is the verb, the sentence which we took from here. So this is the sentence. Lively, we took it from there, and we have mentioned as text2, and that same text2 has been mentioned in here, and we are passing into first tokenizing. So we are tokenizing, then we are making pivot stacks so that our part of speeches will be also mentioned, and then we are using chunks, which is NE chunks, name entity chunks. So now if I run this, you will get the output. If not, there is something missing. So you can see POS tag as error. So yes, POS tag as an error. I'll say what is that? Yeah, I got it. So here, what I have made in here is I didn't have the downloaded option for import pivot tag has been done in here only. So I just remove this code first, and then let me try this. Pivot tag doesn't download for me. So this is because I don't have the process NLTK. Yes, the mistake I have done in here is I did as chunk. That's it. So NLTK import chunk. So now this will work. So now this works. I go with the next code. Yes. So now the chunk pivot tag will get worked. Tokenization will work, and this text will be first tokenized. Text2 will be first tokenized. Then it will be done with pivot stacks. Then it will find the name entities. So then name entity will be assigned into this variable ne, and we will get the values. So next, done. So now the process has been done. Let us see how the ne comes in. So I just print ne. That's it. Sorry, print ne. Run this. You can see it comes with. So you can see now Vistas is not noun, it is an organization. Likewise, it goes, okay, here also Vistas organization. So each and everywhere, wherever it comes with your particularly with name entities who can be, it is not only noun, it is also noun with some other value. So it has been grouped. And also, since we have used the pivot tags, all the part of speeches has been also made. You can see the verb is found, pronouns, nouns, and all those adjectives, directives, everything has been found. And then with that, they have also identified the organizations, which is name entity, which was I was saying about the organizations when you use in here. So this is how we do the process of text mining with NLTK package straight away. So now I have the complete data. So now I can do the analysis. So if I'm not ready to read the complete paragraphs in here, I want to have a quick look what what directly they mean and what they really into about. So then I can clearly fetch all these words, and I can make all these separate groups, and I can use my optimization algorithms, and whatever algorithms I have, I can apply it. So what this text mining does for me is, with this group of data, it takes only the important information, the meaningful information for me for making the analysis. So this is how we do text mining using NLTK package in Colab. So this were the pictures which I saw shown here is by using the Jupyters, which I used to create it. But this time I wanted to show all of you a live example. So that's why I tried with Colab. I think that this also went well. You can also try. So those who have followed me in system, those who are following me in mobile, might also have got these results. If possible, I will also share this sheet with all of you. So I can download and I can share this Python code with all of you. I will also do that. I will also share the slides. You can try. It's very simple to have it. So this is how, so that's what we do, chunking. I think next is, fine. Thank you. So this is my presentation for today. I hope I have given some meaningful information for all of you. Thank you.
Thank you very much, sir, for sharing your profound knowledge with us. Your session was full of zeal and valuable information.
Thank you, ma'am. Thank you. Thank you. Just a second, I couldn't.
Regarding queries, Sendila is willing to ask, sir, do natural language processing supports only text and its value?
Yeah, then NLP is only for languages. If I want to show you one quick example, I can show you with some other languages in Tamil also. Can you just give me any good website where I can get? Okay, just give any Tamil. Okay. Let me take this. So I will show you the how NLP works in other languages as well. Pivot stacks. So just 1 minute of time. So it doesn't works with images, but it does what? Okay, let me take this. Okay, I'll take this paragraph. Whoa, sorry. I'm not good in using this. Just a second. Okay. Am I sharing my screen? No. Sorry.
No, sir.
Okay, good. Sorry, I have just shared. You can see I have copied a paragraph from this Tamil newspaper, okay, Dinamalar. So I have copied this paragraph. And let me show you the PO stacks in here. Straight away, just okay. Text 1 is in here. Okay. Just give text 3 equals to. So this is the Tamil paragraph. So I just enter text This is a paragraph. Now, let me take the tokenization of text 3. So it gives the tokenization process. I think first this should be done. Okay, text 3, the symbol is small. Okay. Text 3. Done. Now, let me try. You can see it works. So this works in all the languages as well. But the problem is, since this is NLP, natural language processing, it can only process the language words, the text words, not any images, but the words in images can be taken. That is possible. You can retrieve the image if you have an image with the text. Yeah, I am sure that you can take the image. I mean, that take only the text from the image, but you cannot analyze the image in here. Am I all clear?
Thank you very much, sir.
Thank you. Thank you, ma'am.
Ladies and
Yeah, please.
yes, sir, you proceed, sir.
Yeah, any more queries? I wanted to ask that. Yeah.
What is the use of bet in NLP?
What is the use of
Bet, BERT, bet in NLP.
BERT?
BERT, bet.
But okay. But is also a step. I mean, once you do the lemmatization, you will also have the BERT option. So based on the tags, I mean, that's what I was while starting. I was saying, when you prepare your own natural language generation, like here, we all of us know what is English, and for each and of anyhow, you will be doing a research for marketing purpose. I will be doing a research for this. I mean, I will be doing a research for health science. Someone else will be doing research for scientific, any physics or chemistry or something like that. In that case, all three of us will be doing only in English. We are going to do some analysis only in the language of English. But the words which I'm going to use for my analysis, the words which you are going to use for your analysis, the word which someone is going to use for his chemistry or physics analysis, I mean, background of information may not be same. So first we need to decide our own set of words. So you have to decide your own set of marketing words. I must decide my own set of words for my research specialization. And the one who does research in physics or chemistry, they have to decide what are the common English words they are going to use. So in that case, in segregating this, we will be using BERT.
Thank you so much, sir,
Thank you.
to solve our queries.
Thank
Ladies
you.
and gentlemen, this is the meal time now. We will be resumed here at 2:15 p.m. Enjoy the meal. Thank you. Once again, thank you all.
Thank you.